Okay, so we talked yesterday about the parts of a circle and where all of those features, the sine, the tangent, and the secant came from. And so those are our main trig functions. And then we talked about the cofunctions and how those cofunctions really mean of the complement. The co means complement. So the cosine is asking us for the sine of the complement of that angle. The cotangent, again, the tangent of the complement. Or the cosecant, the secant of the complement. So if I ask you for the cosine of 12 degrees, that's equivalent to the sine of 78 degrees because those are complements. And let's just punch that in. Cosine 12 degrees is 0.8439. Sine of 78 degrees. Okay, something went wrong here. I bet I've got my settings off again. Let me double check my modes. There it is. I'm in radian mode again. Got to make sure I change to degrees. This calculator automatically resets to the factory presets because it's virtual. Your calculator, once you've changed it to degrees, should stay there. The one check I always do, I know that the sine of 30 degrees is 0.5. So I put that in. If I get 0.5, I know I'm ready to go. So let's try these again. Cosine of 12 degrees, that's better, 0.9781. And sine of 78 is 0.9781. So those are the same value because the sine of one angle, the sine of the 78 degrees, has to be equivalent to the cosine of its complement. Now, I use that example because we don't have a cotangent button on our calculator. But if we really wanted to, we could use that to find cotangent. If I ask you for the cotangent of 23 degrees, I do know that that's the tangent of what angle? What's the... Go ahead.
67.
67, there we go. The complement of 23 is 67. If I could find the tangent of 67 degrees, I know that 2.356 has to be the cotangent of 23 degrees. Now, that's not how we did it yesterday. We used the reciprocals to calculate those yesterday. One thing that we learned or saw with our functions is that the secant of an angle, again, we use theta for that generic angle, is equivalent to the reciprocal of the cosine of the same angle. We learned that the cosecant of an angle, CSC is the abbreviation for cosecant, is equal to the reciprocal of the sine of the same angle. And the cotangent of an angle was the reciprocal of the tangent of that same angle. So, cotangent of 23 should be the reciprocal of the tangent of 23. So if I type in tangent 23, close my parentheses, then use that x negative 1 button for my reciprocal key, I hit enter, I get the same result, 2.356. So one of the things I want to do today is I want to practice using these reciprocal functions. It's a matter of getting the keystrokes down. I want to find the secant of 58 degrees. What trig function matches up with secant? Cosine. It's the reciprocal of the cosine. So what we're going to enter in our calculator is the cosine, enter the 58 degrees, and then use that x-1 key. Under cosine, type in the 58, we close our parentheses, hit that reciprocal key, or the x-1, and we get 1.887. Cosecant, let's say I want to find the cosecant of 41 degrees. Cosecant matches up with the sine. So the cosecant of 41 degrees is the reciprocal of the sine of 41 degrees. So we do the sine of 41. Again, we close our parentheses and hit the x-1. It gives us 1.524. The easy one to remember is the cotangent. If I want to do the cotangent of 68 degrees, that is 1 over the tangent of 68 degrees. So we do tangent 68, close the parentheses, and do that reciprocal key again. Here's 0.4040. Now, again, we got to be careful. The cotangent's the easy one to remember. Cotangent goes with tangent. That's pretty obvious. You would expect those to go together. The other two have always felt backwards to me. That secant goes with cosine, and cosecant goes with sine. It's so tempting to want to put cosecant and cosine together, but they don't. It's the secant and the cosine that go together. So make sure you're very careful. Again, if you're keeping that formula page on the back somewhere in your notebook, that's something to write down and emphasize so you remember that relationship. So I want you to try a few on your own here quick. I want you to calculate the cosecant of 17 degrees, the cotangent of 53 degrees, and the secant of 78 degrees. And we'll go over all the three of those in just a minute. So for the first one, cosecant goes with sine. We're going to type in the sine of 17 and then that reciprocal key. Sine 17, close parentheses, reciprocal. Whoops. Helps if I put all the numbers in there. There we go. 3.420. Is that what you guys got for cosecant? 17? Perfect. For the cotangent of 53, of course, cotangent goes with tangent of 53, then the reciprocal. Giving us 0.7813. And finally, the secant goes with the cosine. So it's the cosine of 78, and then the reciprocal. The cosine 78, close the parentheses and hit the x negative 1. 4.810, it looks like. So again, we're using technically the term is 4 significant digits. It's four non-zero digits is what we're using for our trig functions here. So we can find those values of the non-standard trig functions, the cosecant, cotangent, and secant, by using those reciprocal identities. I want to take a little bit of time here and look at the possible values for each identity, or sometimes referred to as the value restrictions. So if I look at my unit circle, it's important to remember that that unit circle is where all of this comes from. Remember, the unit circle means a radius of 1 unit. And all these trig identities or trig functions come from an angle in here. Let's draw it this way here, and this is my angle theta. We know that the sine, of course, goes from where that terminal side hits the arc back down to that reference diameter. That's the sine of theta. So as we look at this, of course, that could get really small. If our angle gets really small, that sine gets really small. In fact, it can get as small as 0. The largest the sine can get. When we look at it, if this terminal side were straight up, this angle were 90 degrees, the distance from that point back to that reference axis is the radius of the circle. In other words, 1 unit. Sine cannot get bigger than 1. Now we said it can get down to 0, and it can, but it can actually get smaller than that. As the sine goes past 180 degrees, down into here, the sine actually gets negative because it's below the reference axis. So being below the reference axis makes this sine negative. However, there's again a restriction. The smallest it can go would be right here. When it's straight down, that would be -1. So this is telling us that no matter what the angle is, the sine of that angle has to be greater than or equal to -1 and less than or equal to +1. So if you calculate the sine of an angle, let's say you calculate the sine, and we call it angle alpha, and you come up with 1.08, that can't be true, because sine has to be between -1 and +1. Well, let's look at the cosine for each of these angles. The cosine just goes to the complementary reference axis, or the vertical reference axis. That is the cosine of theta. And we see that is inside the circle, just like the sine is. Largest it could be is right here when it's +1. Smallest it would be over here when it's -1. So just like the sine, the cosine of an angle has to be between -1 and +1. So those are two restrictions that are very important for our trig functions. If you ever get into a situation where you're trying to do an inverse trig function and you have a sine or a cosine that's larger than 1, you can't reverse that because it just can't happen. The sine or cosine cannot be outside of that range of -1 to +1. So I'm going to draw a clean unit circle here. So let's look at the secant and cosecant. So let's put my angle out here, again like this. This is my angle theta. Now remember, the secant is made by extending that radius out of the circle until it hits where it intersects the tangent. Well, the secant has to extend outside the circle. And remember, this length here is a radius of the circle that has to be 1. So the length of that secant is always going to be at least 1. Now it's a little less obvious, but there are points where that secant will be negative. Because the secant is equal to the reciprocal of the cosine, and obviously the cosine can go from -1 to +1, so there's times when the cosine's negative. The secant has to be negative as well. So the secant of an angle has to be either less than or equal to 1, or, sorry, less than or equal to -1, I should say, or greater than or equal to +1. So the secant of an angle can't be between -1 and +1. It has to be outside of there. It has to be either smaller than -1 or larger than +1. In other words, the absolute value, the length of the secant, has to be 1 or more. Now, since the cosecant would be the secant of the complementary angle, we have a similar thing. So the cosecant, if I draw this tangent here, the cosecant would be this length. It still has to extend outside of the circle, so the exact same restriction occurs on the cosecant. The cosecant of an angle has to be either smaller than -1 or bigger than or equal to the +1. Let's look at tangent. That one almost looks like a circle even. So if we put our angle on here, there's my angle theta. Remember, we find the tangent by extending that up until it hits that tangent. The length from where it hits that secant down to the reference axis is the tangent of theta. So if we adjust our angle, we can see how that tangent changes. If I make my angle down here really small, that tangent is close to 0. If I made it the angle 0 degrees, the tangent would be 0. If I make my angle really large, I see my tangent extends way up there. That tangent can actually become infinite. If my angle here were almost 90 degrees, so something like this right here, it's going to have to go up a long ways before it intersects that tangent up there. It's going to be way up there, nearly infinite. In fact, at 90 degrees, the tangent is infinitely large. And of course, it can be below the axis too. We could have values, tangent going down here would be a negative length. So the tangent of theta can literally be any number, any value. And of course, the cotangent is in the same boat. So there are absolutely no restrictions on the possible values of tangent and cotangent. But sine, cosine, secant, and cosecant have definite restrictions upon them. The reason I bring some of that up is because we are going to look, one of our next things to look at is inverse trig functions. As we've looked at our different functions along the way here, we have our different operations, as I say. We found that our operations come in pairs. We call them inverse pairs. We found that adding and subtracting are inverses. They undo each other. If I add 6 to a number and then turn around and subtract 6 from that result, I'm right back to where I started. Or the other way around, if I subtract something and then I go and add it back, I get right back to where I started. Multiplication and division are a set of inverse pairs. They will reverse each other. If I multiply by a number and then turn around and divide that result by the same number, I get back to where I started. Or if I divide by a number and then multiply that result by the same number, I'm back where I started. We found powers and roots. Are an inverse pair. If I take 5 to the power of 4, I get 625. If I take the fourth root of 625, it gets me back to 5. Having a power and then a root with the same index as that power reverse each other. They undo each other. Well, in trig functions, we have the same thing. If I have the sine of 30 degrees, gives me 0.5. Have to have some way to get from that 0.5 back to the 30 degrees. And that's an inverse sine. Now, there are several different notations for inverse sine. There are 3 of them that we're going to see in here. The simplest one is just that, INV-SIN, inverse sine. Another common one is arc sine. We talked briefly about radian measure in our angles, where on our unit circle, if this is our angle here, that might be 30 degrees or whatever, the length of that arc is another way of measuring that angle, and it would be radians. That would actually be pi over 6 radians would be the length of that arc. And we could define that angle to be pi over 6 radians. So in arc sine, that's what it's referring to, is it's going back to the length of that arc to get the angle. The most common notation that you see, at least in mathematics, is sine with a little -1. Now be careful, that -1 is not a reciprocal in this case. It does stand for inverse. There is a huge difference between sine -1 of 0.5 and sine of 30 to -1. This is an inverse sine. This is a cosecant of that angle. So be very careful with that notation. I know it is very confusing having that -1 there to represent the inverse. The key is the -1 is attached to the sine function itself, not to any of the numbers. Here, the -1 is attached after the number. So if I have the inverse sine of 0.866, how do I calculate that? Well, on our calculators, most years I believe have forward notation. If you have some of the old one-line calculators have what we call reverse notation. But anyway, we put in the 0.866. Oops, sorry, clear off. If you have reverse notation, you'd put in the 0.866 and then do the inverse sine. For our calculator, you have to enter the inverse sine first. And you can see above the sine key, it says sine -1. That is the inverse sine. You hit that key, then you put in the 0.866, and you close the parentheses, and it spits back 59.997, or in other words, 60 degrees. So that's saying that the sine of 60 degrees is 0.866. So if I have the inverse cosine of 0.42, we're going to do the same similar thing. It's second cosine this time. See, we get the cosine -1, or the inverse cosine. 0.42, and close those parentheses. 65.17 degrees. Now we said our trig functions themselves are rounded to 4 significant digits or 4 non-zero numbers. Angles are typically rounded to 2 decimal places, so hence the 0.17. And we might have the inverse tangent of 0.85. Second tangent 0.85, close the parentheses. I get 40.36 degrees. What is wrong with what I just wrote there? Inverse sine of 1.38. Well, it's asking me what angle has a sine of 1.38. If I try to punch this in my calculator, second sine 1.38, close the parentheses, it gives me an error. Why is that? Well, because the sine always has to be between, I'll put sine of A has to be between -1 and +1. We cannot have a sine of 1.38. So if we're doing an inverse sine, we cannot take an inverse sine of 1.38. There is no angle that will give us that sine. Inverse tangent of 40.5, is that allowed? Yes, remember we said tangent can take on absolutely any value. So we can do an inverse tangent of 40.5. Just second tangent, 40.5, close those parentheses. It's 88.59 degrees. Inverse cosine, before I write it in, what do I know about the number that goes in here? The sine, it has to be between -1 and +1. But let's try a negative number. Let's put in a -0.65. So I'm going to do a second cosine, -0.65. Hit enter. Oops. Let me try that again. Second cosine. I got my second register. Second cosine, -0.65. And I get 130.54 degrees. Let's look again at where we saw the possible values of our trig functions off of the unit circle. let's look again at where each of these values, each of these functions, is positive or negative. If our angle is over here, and this is called the first quadrant. In other words, that is between 0 degrees and 90 degrees. This is the sine that's above the axis, that's positive. The cosine would be over here. Well, the right side of that vertical axis is the positive side. So both the sine and the cosine of an angle is positive if it is between 0 and 90 degrees. Well, over here in the second quadrant, which is 90 degrees to 180 degrees, let's put my angle in there. This is my sine. Sine is still positive because it's above the reference axis. The cosine, however, goes to the left of that coaxis or the vertical axis. The cosine there is negative. So that's why when we did an inverse sine of a negative 0.065, we knew we were going to get an answer of between 90 and 180 degrees. Well, let's look in here. In the third quadrant, where the angle is between 180 degrees and 270 degrees. Here now the sine is below the axis, so the sine of that angle has to be negative. Well, the cosine is still to the left, so the cosine of that angle is also negative. And finally, over here, where our angle is between 270 degrees and 360 degrees, remember 360 degrees is equivalent to 0 degrees. The sine is still below the axis, so the sine of that angle is still negative. The cosine of that angle, however, is on the right side of that vertical axis. It's positive again. So you look at it in this circle, there are two sections in that unit circle where the sine is positive, from 0 to 90 degrees and 90 to 180. And then there's two sections where it's negative, from 180 to 270 and 270 to 360. So basically the sine is positive up here and negative down here. The cosine also has two spots where it's positive, but it's 0 to 90 and 270 to 360. The cosine is positive on the right side of the circle. And the cosine is negative over here, basically between 90 and 270, from 90 to 180 and 180 to 270. The tangent is a little bit trickier to figure out because the tangent doesn't go off just, is it above the axis or below the axis? The sine of the tangent, if we look at what sine was, opposite over adjacent, and we'll talk about this way more when we talk about identities coming up in the next couple classes. We know the sine of the angle is the opposite over hypotenuse, and the cosine of that angle is the adjacent over the hypotenuse. If I divide the sine divided by the cosine, that would be opposite over hypotenuse divided by adjacent over hypotenuse. In this case, the hypotenuse divides out, and I have opposite over adjacent, which is what the tangent is. So the tangent, one of the identities for tangent is it's the sine of the angle divided by the cosine of the angle. Why do we care about that right now? Well, because we want to know where the tangent is positive or negative. Well, the tangent will be positive where both the sine and the cosine are positive, and it'll be positive where both of them are negative. Remember, when we divide a positive by a positive, it's positive. But also, if we divide a negative by another negative, it's positive. And if we divide a positive by a negative or negative by a positive, that's a negative. So the tangent is negative where the sine and cosine are one positive and one negative. Monday, we will go over inverse functions for secant, cosecant, cotangent, how those keystrokes are used. For right now, in your packet, it is page 341 to 342. Problems 55 to 121, the odds. Finding the value of those functions, and then finding the inverse function to get back to the angles. So we have about 13 minutes left here. I'll let you have that time to get started on the homework if you like. I will be here to answer any questions if they come up. Otherwise, that is it for new material.